Excellent. All right. In that case, let us begin. And let me remember to do the extra thing I need to do. Oh, that's disappointing. Share sound is disabled for me. Is there anything that we can do about that, or are we out of luck?
I can hear you. Sorry, what's wrong?
I can't share sound. I do have a clip. And this somehow, share sound is not enabled for me. I don't know if that means that I just need to be promoted in some way.
JB, I was able just to share sound without enabling anything, so it may just be enabled.
Let's see if it works then. All right, we'll do it live. Awesome. Legacy Systems, everyone. Welcome. Okay, so thanks very much for inviting me to be part of the 10th birthday celebration. It's really nice to, one of the things that marks the career of a consultant, or indeed any kind of freelancer, is not knowing what happens after you leave the room. Often you show up for a week, 2 weeks, a month, some relatively short period of time, sometimes as little as a day. And then you have no idea what happens after you leave the room. And that can be unsettling for somebody who actually wants to feel that fulfillment of having some kind of an impact, of knowing that you've done something to help people, and that you're not merely shouting opinions into the void, which I can tell you that over the last 20 years, it's felt a lot like that. And so when, when you reached out to invite me to this, to be part of this, that was a really nice way to let me know that something I said worked in some way for somebody and help them in a meaningful way. And so I'm really happy to be here. But let's get on to the show. So you'll notice a slight difference in the title: Beware the Integrated Test Scam. So I'm here to do 3 things today: to look back, to apologize, and to offer what I hope is some hope for the future. So I'm curious, does anybody else out here remember extreme programming? Maybe not everyone has quite the same amount of gray that I have, but if you're a programmer of a certain age, then you might remember when extreme programming started to become popular in the late 1990s and early 2000s. And there were a couple of things that I really remember from that time. One of them was all the jokes about the X Games, about what extreme meant. Does that mean that you're going to be programming on BMX bikes? Are you going to be rappelling off the side of a mountain? No, that's not what we meant at all. But the other thing was, especially if you managed to read the first edition of the first extreme programming book, Extreme Programming Explained by Kent Beck, you might recall, and I don't think Kent will mind too much my saying this, the ramblings of a frustrated programmer, or maybe a swift call to action from a frustrated programmer, someone who wanted to lead a programmer revolution. I remember at one point Kent calling computer programmers the world's richest oppressed group. And what came out of that was a whole bunch of, as I say, exuberance and bold statements. That was the extreme in extreme programming. It had nothing to do with X Games, and it had everything to do with, one of the old sayings was, if this is good, why don't we do it all the time? And so in the extreme programming community, we made a bunch of bold statements. You should do it this way. It needs to be like this. If you do this, it will be better. Turn feedback up to 11, turn courage up to 11, turn communication up to 11, and see what happens. And I think, as far as I understood it, the original idea was, let's scream, let's get as many early adopters as possible, and then see what happens and how they carry the ideas to the rest of the community. A bunch of us had been reading the Crossing the Chasm had come out around the same time. And so the idea of how do we cross that chasm from the early adopters to the general majority was a big question. And a lot of people liked what we had to say. I mean, I certainly liked it. I got sucked in. I'm here today in part because I read those books. But a whole bunch of people were suspicious of us, and not just the ones making jokes about extreme, but the ones who kept telling us that in the real world, it didn't work that way. And so, we had this vision for what we thought the future could be. And we screamed about it as loudly as we could. And then we had to pivot to addressing the masses. When it came time to cross that chasm, frankly, I think our marketing message wasn't up to the task. I think we didn't have enough people who had expertise in the differences between marketing to the early adopters and marketing to the general majority and the latecomers. And so depending on when you start counting, we've been trying to clean this mess up for anywhere between 15 and 25 years. And I think by and large, most of us have given up. And now there's a small group of still relatively rabid fans of extreme programming. And some people like me who really cite extreme programming as being a huge part of where we came from, but who don't quite have the same kind of extreme fervor that we used to have. I think we hold many of the same convictions, but we've gone not only away from the firebrand marketing, we've even dialed back on the strong opinions weekly held, and it's more like, hey, this is a really good place to start. This is a really good tool set to have in your toolbox, but it's probably wise to be able to do other things as well. And I mention all that not because extreme programming is so relevant to what I want to talk about today, but more because I see a really big parallel between the path that we've been on with collaboration and contract tests and what the extreme programming community has gone through, where we're older, we're wiser, we've seen more things, we've seen where our ideas work and don't work. We've seen the struggles that people have and don't have in trying to adopt what we're trying to sell. And we've learned some things along the way, and maybe our message is a bit softer than it used to be. So let's see if sound works.
No sound. But
no sound?
No, unfortunately not. I've promoted.
Oh, that's a pity. It's only 20 seconds, so it'll be over soon. You can imagine what it sounded like. This is the opening to integrated tests are a scam. The huge, the world is going to end. Integrated tests are going to kill you. It's going to destroy your life. And I played that once. And in fact, you know what? It's even better that you didn't get to hear it, because I never want to hear that again. I'm embarrassed by that now. I mean, I understood what I was trying to do at the time, and I don't necessarily blame myself for it. I did the best I could at the time, but that tone's all wrong. The ideas in that talk I still stand behind them, but the tone is all wrong. And so now when I talk about integrated tests and when I talk about the difficulties, the scam is still there. I really want to emphasize that the ideas are the same, but the delivery has changed. Not just kinder, gentler, because I want to be kinder and gentler, but because it's not quite as, I don't think I need to shout from the rooftops anymore like I used to. I did that for 20 years. I'm happy to have done that. I did it for the first time in 2003 at the SD West conference. It was the first time anyone was willing to listen to these ideas. I think I got it all out of my system now. The scam hasn't changed, but what's changed is how I present these ideas to clients, to colleagues, to peers, so that they recognize that there is a hole. Please don't fall in the hole. I'm not necessarily going to scream that the house is on fire, but I will point the hole out. If you fall in, I'll help you get out, and then you'll realize, oh, I don't want to fall in that hole again. So let's say, beware the integrated test scam. Now, I'm not sure I've actually told the story before, where scam came from. My wife, Sarah, the queen of docs, who is now a celebrity in the Astro project community. She had her conference while I was gone at this bowling tournament. She spoke at VeetConf and was a big part of it. So congratulations to her. She likes to call everything a scam. That's her joke. Insurance is a scam. Anything that doesn't work as advertised is a scam. And I found that funny. So because integrated tests don't necessarily work as advertised, it became a scam. From that day, at the time, integration tests were a scam. That was the joke. And I thought, even though it's just an inside joke between my wife and me, I think others will kind of get it. But of course, Jerry Weinberg's The Law of Raspberry Jam kicks in, right? The wider you spread it, the thinner it gets. And I think a lot of people took the scam part a little too seriously. So even before I changed integration test to integrated test to try to clarify that part, the scam part, I think, is the part of my legacy that I'm not particularly happy with. But if you let it be a joke, if you let it be hyperbole for the sake of humor, then I think it stands. I mean, integrated tests will destroy your code base if you let them. They will slow you down. They will cause you to not trust your tests. And they will force you to duplicate effort. And the more you rely on integrated tests, the more expensive they become. It's like buying medicine that makes the disease worse. This is the only metaphor that I found that actually helped really explain my position. And since maybe not everyone is so familiar with the talk, the very short version of integrated test is any test that runs more parts of the system than you're trying to check. So if I'm trying to check this part over here, if all my assertions are concerned with, one value or with one set of side effects, but I'm forced to run a larger part of the system in order to check that, that's an integrated test. And the opposite, you can call it a solitary test, an isolated test, a micro test if it happens to be small enough. Let's not go down that rabbit hole. But the opposite is some kind of focused test, a focused unit test, something that runs only the part of the code that you're trying to check. And of course, the goal isn't to make every test as small as possible, but rather to understand that if you allow your tests, if you rely too much on tests that run more of the system than you're trying to check, then you're going to slowly, gradually stop trusting your tests. Because 37 tests will fail even though there's a tiny problem over here. And so somebody will stop the line. There'll be a quick stand-up meeting. People will be panicking, and somebody will realize that it's a tiny typo somewhere. That's not a big deal. If 2 unit tests failed, then you'd have a very different experience. And so the integrated test scam is that if you rely too much on integrated tests, it's like buying medicine that makes the disease worse. And you can mitigate this damage with attention to detail and particular techniques. There are other ways to do it. You can even live with the damage if you want. But there's a very nice thing that happens. If you try to do the kinds of things that help mitigate this damage, working with collaboration and contract tests, programming to roles and interfaces, we'll get there in a moment. Trying to mitigate the damage actually nudges you towards designs that are in some ways better, that create more reusable pieces, more recombinable pieces, and that teach you something about design. One of the things that I hear repeatedly is you can't do good test-driven development until you understand design. And I can't have this argument anymore. Well, no, I can. If you pay me, I'll have the argument as much as you want. But I believe that you can learn those principles of design deeply, internalize them, and they're yours for life through practicing test-driven development. As you try to practice test-driven development and you notice things like the integrated test scam, and you adopt the idea that if the tests annoy me, the problem is with the production code design, then you can learn all the principles of good design and own them for life. Learn them at a pace that you will actually understand them and be able to apply them and actually use them as part of your work, instead of it just being ideas in dusty books on the shelf that you never look at anymore, that you read once and put away and never use. And for me, maybe the most important part is this last part. You can do it. There is no need to fall for the scam. You can figure this stuff out through practice. It's good to have people like me, like the people who supported me when I was growing up, to be able to ask questions, to be able to ask the biggest question, which is, I tried to follow the rules and it made me do a thing that seems wrong. What does that mean? Now, 20 years ago, it was a lot easier to just go to Google groups where everybody hung out. They were all in one place. You could ask them a bunch of questions and probably get 20 good answers in a day. It's a little harder these days, right? The social media landscape and even the website or community, the sort of online community landscape more generally has become much more fractured. Do I go to Quora? Do I go to LinkedIn? Do I go to X? Do I go to Mastodon? Other parts of the Fediverse? Lemmy? I have no idea. But if you wander around the desert, you will find your tribe. You will find the people whom you can count as trusted advisors. I'm willing to be one of them. As long as you're willing to wait forever for the answer, that service is free. And if you need a better service level agreement, we can talk about how much that costs. But the important thing is you can learn this stuff. You don't have to. It's not life-threatening. But you don't, if you find yourself in a situation where you feel stuck from these integrated tests, there is a way out. You don't have to be a wizard to do it. You can learn it as you go. And I promise you, it's not as hard as you think. Now, all of that is not nearly as catchy as integrated tests are a scam. They're going to destroy your code base. They're going to drive you insane, and your life will be over. I admit, it's not as catchy, but it has the advantage of actually being true. I believe that those points that I made moments ago are a much more accurate representation of the situation. And if you caught me at a conference, or if you asked me a question in a nice, private, quiet moment, even 20 years ago, well, maybe not 20, 15 years ago, I would have said those things. But I thought I needed to shout it from the rooftops to make people listen to me. Marketing is hard. I had to feed my family. Now, the integrated test scam hasn't changed. Here it is in a nutshell. This is almost the same diagram that I drew for the first time 20 years ago. And it starts with, at the top, our tests are all passing, but we find a problem. And that, almost by definition, is an integration problem. If you do even a reasonable job of writing any kind of unit test at any scope of the system, and especially if you try to write smaller and smaller tests, it seems likely that the behavior of the individual pieces will be what you expect. But then when you try to put the pieces together, they won't quite fit. And this is the kind of thing that causes people to say, oh, we must have holes in our testing. Let's go to the testing pyramid or the testing rhombus or whatever the hell people are calling it now. But they start saying things like, we have holes in our testing and we need to fill those holes in. So you can use the Swiss cheese approach. There's a whole bunch of things out there that you can learn. But what seems to happen is that at some point, someone who thinks they're playing the role of the adult in the room, a senior programmer, an architect, a well-meaning project manager, a well-meaning product owner who is a former programmer, will say, well, you need system tests, end-to-end tests, some kind of bigger test so that you can fill in the gaps. That's one of the layers of cheese in one of the cross sections in the Swiss cheese thing. Okay, it's a choice. I want you to be aware of one of the key risks, and that is that integrated tests, by their nature, run bigger parts of the system than we're trying to check. That's the definition. And especially end-to-end tests are the biggest integrated tests you could write. Big tests have one serious flaw. If you use them as part of test-driven development, and particularly if you're in stage 2 of test-driven development where you're doing test-driven design, where you're really relying on tests to give you feedback about the quality of your design, bigger scope tests put less stress on the design. So dependency problems are not as apparent from tests. Now, you'll still have duplication in your tests, but the one thing I've learned over 20 years is that programmers can get numb to duplication in tests pretty quickly. So maybe it's not as good a feedback mechanism as I think it is. But for those who are willing to pay attention, once you get hooked, it becomes really nice. But sort of getting that first taste seems to be difficult. And so what that means is that because those tests put less stress on the design, it's possible to write worse code that passes those tests. You can write code where it's a tangled mess inside, but because the tests are checking they're running the system and checking from an outside perspective, there isn't as much pressure on the design to be nicely organized. And because we are programmers and we're productively lazy, that means we will write less bad or less good design to pass those tests. Even if we think we're doing a good job, again, we're productively lazy. We are also human and we want to conserve energy. So we are going to write code that passes the tests. And because the tests put less stress on the design, we're not going to notice the design flaws as easily. As a result, we will have more tangled code. I'm not saying the whole thing is a tangled mess, but you'll have islands of tangled messes, and some of them could get quite big. Once 2 or 3 of those little islands of tangled messes become tangled with each other, now you have legacy code. Congratulations, that's a whole other talk. But there's another effect, that because the code becomes more tangled internally, it becomes even harder to write good unit tests. So now you're forced to write integrated tests in order to test more of your system. And the tests become wider in scope. They become more brittle. There's more hyperactive assertions that fail even though everything is fine, or explosions in the wrong building, or failure, one tiny thing causes 118 tests to fail and everyone panics. And so that makes the problem worse. What that means is that we write fewer tests because writing tests is painful. It's painful to write them. It's painful to run them. They become a pain in the ass. So as a result, we write fewer of them. And when we write fewer of them, then the thing at the top, 100% green, and yet there's a defect, becomes more likely to happen. And that is the amplifying feedback loop. That's why the dude in the center of this diagram is freaking out. Because trying to use integrated tests to solve the problem of the tests are passing and there's still integration problems causes you to have more integration problems. Now, in principle, in practice, you can find an equilibrium, right? There is a balance to make between smaller tests and bigger tests. The bigger tests are not ever going away. You might need them for different purposes. You might need them to help give the customer the warm, fuzzy feeling that the system is working the way they intended, because your customers, your stakeholders, your product owners, whoever they are probably not going to trust your unit tests, no matter how good they are. Some have, some do. I've experienced it a couple of times, but most of the time, no. But you know what? They actually don't trust your automated tests at all. On average, spherical product owners in a vacuum, they don't care about your tests. They only care about what happens when they use the system, or when someone they trust uses the system, or when someone they trust tests the system by hand. And so you can go look up James Shore and the phrase customer unit tests. And what James has to say about the myth of automated acceptance tests, I kind of agree with. That for the most part, if we really want to do the extreme programming thing of getting a real customer, a real user to accept our features, seeing is believing, and they're not going to trust your automated tests no matter how many nice cells turn green. No matter how much you try to tell them that those automated tests mean that we understood them and that it works, unless those customers are recent programmers, they won't care. They'll yawn and they'll still have to play with it themselves. So don't waste your time. The integrated tests are probably not going to help. You can gradually replace them with smaller and smaller tests that do a better job. So now what do we do to avoid the scam? So whenever there's a risk, you look for mitigation strategies, limit the damage, and you look for avoidance strategies. Best way to block the kick is not to be there. So what are the mitigation strategies? And this is one of the key arguments that people make against the old integrated tests are a scam idea is, well, not always. Not all integrated tests. Fine, I agree. If your object clusters or module clusters, I'm going to say objects because I'm an old dude and so I think in objects. If your object clusters are small enough, 2, 3, 4 layers, then the integrated tests, the combinatoric explosion is still there. But if there's only 3 or 4 layers in your tests, like 4 factorial is not that big. It's only 24. The combinatoric explosion has not had a chance to explode yet. At 6, 7 layers, you're dead, right? Your project is over. We're already now firing the CTO and doing it again in Python and swearing that we're not going to make the same mistakes again. So if you make the clusters small enough, then the problem is probably never going to hurt you. It'll annoy you. And the nice thing about that is you'll never have the urgency that makes you think, oh, wow, we absolutely have to stop everything and replace all of this with microtests now. You'll never have that impulse. You'll just have this gnawing feeling that, maybe we should try to move towards smaller tests. How might we do that? How do we disentangle what we've built so far so that when we write a test, we can run a smaller part of the system that's more focused on the part that we're actually trying to check. So that's the risk mitigation strategy. As long as we avoid relying on end-to-end tests, it's probably not that bad. The problem is that most projects that I see these days overspend on end-to-end tests. Like they're literally, even if they're avoiding the UI skin, they're going from HTTP endpoint all the way to the end and coming back. At most, they're stubbing out the database. That's not bad, but I'm not sure those clusters are small enough. And if you try applying some of the ideas in collaboration and contract tests, one of the things that will happen is that you'll discover the hard lines that make sense between, say, the skin of the UI, the HTTP transport mechanism, the database at the back, or whatever backend you happen to have. Again, old guy, so I think database, but of course, I know the backends are all distributed these days anyway. And then what's inside is this GUI mess that could be a domain model. And if you work on that a bit and apply the collaboration and contract tests idea to that part of the system, magic can happen. Then you really could live the dream of testing your business rules with no thought to the technology integration. And so then when somebody says, we need this working on mobile, you can do it. When we need this working on a new browser, we can do it. We need to, REST was a mistake. We need to do something else instead. You can do it and just change a part that is pure technology that has nothing to do with the interior of your domain. And I think that's sort of the thing that's missing right now. If you do that, then the clusters will be so small that you can afford to have some clusters of objects inside your domain, and you can afford to have some clusters of objects that are pure technology integration. And as long as the two never mix, you're probably in great shape. So that's the mitigation strategy, is to make the clusters smaller. We don't have to do collaboration and contract tests absolutely everywhere. But if you've never done it before, or if you don't feel expert in it yet, you might need to do it everywhere to find out where it makes sense to do it and where it's mostly a waste of time, right? The only way to know where the edge of the cliff is to fall over a few times and then say, now I know where the edge of the cliff is. Don't go any farther. And then avoidance is the other strategy. Just don't do it. So that's where collaboration and contract tests come in, client-first design with test doubles, all the kinds of techniques that, I and people like me have been teaching for 20 years now, where we just decide we're not going to play this game. We're going to program to roles or interfaces or protocols, whatever you want to call them. And we're just going to do it everywhere as much as possible. And you might be overpaying for a guarantee. Again, that was one of the primary arguments against my idea was, JB, you're overpaying for a guarantee. Yes. But again, you need to overpay for a while to understand how much is worth paying. And a lot of people had just never even thought of this before. You can smack a person over the head as much as you want with object-oriented design or books like that. But until they've actually tried to use collaboration and contract tests in a real project under real pressure, they don't understand what it means to do that, what it means to program to roles, interfaces, protocols. This is maybe the first time in their career they've ever actually tried to do it and understood what it meant. And so you need to overdo it before you know how to do it enough. You need to underdo it, which is most of your career up to this point. You've been underdoing it. Then you need to overdo it for a while. That's what we did collectively in the early 2000s. And then we settled down. That's a natural part of the learning process. You need to allow yourself to do that. It's okay. It's okay to have a bunch of interfaces with one implementation. Nobody will shoot you. Some senior programmers might look at you a bit funny, but whatever. This is what it takes for me to learn. Let me do this. It's fine. So what do collaboration and contract tests lead to? As I've been saying, they lead to understanding this thing that people have been writing about since the 1950s, about programming to abstractions. All those old papers that the old people have been showing you that you didn't waste your time reading will start to suddenly make sense. I mean, the examples in like lambda calculus, maybe not, but the ideas will. Suddenly it's like, woo, now I get what they were trying to do. Not only indirection, but also abstraction. Abstraction is one of those words that senior programmers use to make junior programmers feel stupid. But if you ask the senior programmers what abstraction means, if you put 5 senior programmers in a room and ask them what abstraction means, I will pay you 1,000 currency units, 1 million depending on the currency, if 2 of them agree. So let me tell you what I mean by abstraction. An abstraction is a thing that hides details. End of sentence. That's it. Helpful abstractions hide the details that you don't need and expose the details that you do need. Unhelpful abstractions either hide the details that you need or expose the details that you don't need. And finding a balance in abstraction, it's a balancing game. You don't stop. Sometimes, from different perspectives, different abstractions of the same thing are useful. Think of a car. For most of us, and I shouldn't say us, for most of you, because I don't drive, for most of you, I've only ever driven twice, both of them illegally. Statute of limitations has expired, it's fine. The interface of a car is essentially the steering wheel, the pedals, the ignition, and that's it. That's the basics of how to use a car. And that's all you need to know. For most of us, we're not going to tinker with the car. We're not going to repair the car. We're going to pay somebody else to do that. All we need to know is how to make it move. That's abstraction. And a car provides some, learning to drive a car relies on a helpful abstraction of the car. You don't need to know more than steering wheel, mirror, ignition, pedals, how to get in and out of the car, how to lock it. I mean, really, what more is there? That's abstraction. Hiding the details that you don't need until you need them. And different abstractions are of different value to different people. So when some of my peers talk about bad abstractions, I don't believe such a thing exists. Sorry, folks. There are abstractions that are helpful to some people in some moments, and there are abstractions that are less helpful to those people in those moments. And I think of it that way. Do you hide the details that I don't care about right now, and do you expose the details I need? And collaboration and contract tests is not just a testing strategy, but it's a design strategy to gradually converge towards helpful abstractions everywhere. Helpful abstractions everywhere, at every layer of the system. And you don't need to extract interface types to get abstraction. You can use public-private. You can use naming conventions and pretend that the names, that the methods that start with underscore don't really exist. However you do it. But you understand that there's part of this module's interface that clients will talk to and part that they don't. And whether you enforce that with types or do it by agreement doesn't really matter. What matters is having ways to challenge the value or the helpfulness of the abstractions. And collaboration and contract tests constantly put pressure on our abstraction decisions, on our encapsulation decisions, on our hiding decisions. And again, when the tests are annoying, maybe that means that we're hiding some details that would be useful, or we're exposing some details that are getting in the way. And so we adjust the abstraction level. So again, some of my peers have said, I would gladly exchange duplication to avoid bad abstractions. I'm sorry, I don't get it. Like, why can't you refactor your abstractions? Why can't you make something visible that wasn't before? Why can't you make something invisible that used to be visible? Improve your refactoring skill and that problem goes away. I mean, it has a cost, but the whole point of refactoring is to allow us to not feel imprisoned by our decisions. And one of the nice things about working with collaboration and contract tests is they constantly challenge our choices about abstractions, and they help us. Some would even say force, I don't like to use that word, but they really do strongly encourage us to challenge our ideas about what abstractions are helpful. And when the test doubles in our tests become too complicated, that's a sign that there's some details being exposed that should be hidden. And when we have trouble writing a test at all, then that's a sign that there are some details being hidden that need to be exposed. The nice thing, even if you extract interfaces, the really nice thing is that you can always just write test implementation directly if you need access to those details, right? The mechanic cares about the interior details of your car's engine, even though you, the driver, couldn't possibly care less. And so one of the nice things about using collaboration and contract tests is that they help us address design problems before they get out of control. They're the early warning sign that this interaction is starting to become too complicated. Maybe it's better summarized by an intermediate object. Maybe you need a proxy here. Maybe you need the specification pattern. Maybe you need an adapter. That is what these, yes, these are testing strategies, but to me, really, they are design strategies. When the tests become annoying, look at the design and see what you can do to make the test simpler. They provide that positive pressure that we're looking for. If you do this long enough, you end up here. So this is another one of these magic phrases that I stumbled into about 10 years ago, that especially at the dawn of the distributed microservices revolution, if you want to call it that, this started to speak to people. If I say program to abstractions and you just glaze over, then if I say microservices in a single process, people perk up. Ooh, he said microservices. Ooh, let's find out. And that's what happens when you try to apply collaboration and contract test to your design. What you end up with is effectively microservices in a single process. And if you have microservices in a single process, how hard do you think it will be to extract those microservices into distributed parts? Not very. And in fact, one of the when people ask me, how do I test my system with distributed microservices? I say, well, get rid of all the HTTP nonsense and arrange those microservices in a single process and try to test them using collaboration and contract tests. And if you have trouble, then you're going to have the same trouble when you make those microservices distributed. There's going to be messages going in both directions. There's going to be message spaghetti. You can see that message spaghetti in tests if you try to write collaboration and contract tests for the in-memory version part of all that. So strip away all the HTTP crap, leave behind just the part that can run in a plain process, and then try to write collaboration and contract tests. And if you can't do that very well, then you certainly are not going to enjoy your distributed microservices experience. And the opposite is true. If you do this well, then when it comes time to distribute your microservices, not going to be a problem. It just becomes tedious work. You might write a code generator to do it. In fact, that's how all these magic whiz-bang, we're going to make your code magically microservices overnight. The stuff that they were telling us about at the beginning of the service-oriented architecture craze, that's where those tools came from. So ultimately, this message, I intend it to be kinder and gentler. Less of you're doing it wrong and more of, hey, you might feel some pain here. Are you feeling pain? I can help you. Now, I admit, the second message has some marketing problems in its own, right? As soon as somebody says to you, I know how to relieve your pain, the first thing your critical thinking faculties should make you ask is, did they engineer the pain so they could sell me the cure? Fair. I don't think I did. I think the pain comes from how difficult it is to learn good design principles from books and articles and courses. Because programmers, and especially young programmers, eager young minds that are trying to learn everything, try to read their way to proficiency, to expertise. And I don't believe you can. I believe you can only practice your way to proficiency and expertise. And reading, taking courses, talking with mentors is a way to push the fast forward button from time to time. But you can't read a book on object-oriented design or functional design. I mean, Grokking Simplicity is a wonderful book, but I don't think a programmer who, if you pick a random JavaScript programmer off the street and say, read this book and then come back to me and program magic, it's not going to happen. They need an opportunity to try it and make mistakes. And there's no point in yelling at them that they're doing it wrong. All that does is make them feel bad and make them feel less eager to try. I do not want to squash their eagerness. Instead, I want to adopt sort of the relaxed grandfather stance and say, look, programming is hard, design's hard, and the learning materials really aren't that good. So when you have questions, come here and I'll give you a little morsel of wisdom, and you'll go away and you'll try a bunch of stuff, and then you'll come back. And you don't have to learn it all at once, I promise you. It's enough to just know this. If you write integrated tests, then you run the risk of making your tangle problem worse. If you rely too much on integrated tests, that tangle problem is probably going to get worse. And at some point, you're going to want to just flip a table and start again. Don't let that happen. Before it gets to that point, come back and ask me a question. And now when you've asked me the question, hey, have you thought about trying to do this thing called collaboration tests? And then when they've done that for a while, then at some point they'll come back and say, well, I don't know how to make the collaboration. I don't know how to trust my collaboration tests. Okay, now, have you heard about this thing called contract tests? Because contract tests will help you fill in the gaps in a way that's more effective than integrated tests. You'll probably use both together, but I think most people over-rely on integrated tests and under-rely on contract tests. And yeah, it's not as flashy. It's not going to make the main stage at many conferences, but it's going to be a hell of a lot more effective. When you feel the scam taking hold, here's how to protect yourself. That sounds lovely to me. Not, you're doing it wrong, but look, this is a thing that happens to everyone. It's part of the learning process. Don't feel bad. When you start to notice that adding more integrated tests doesn't seem to make the situation better and might even be making the situation worse, come here, yell right here. And after you've got that out of your system, we can talk about what step to take next. And if you're not feeling any pain, then I guess everything's cool. Maybe you have accidentally mitigated the problem by making your clusters small enough. Works for me. If there's no pain, then there's no scam and there's no problem. Keep going. When you start to feel pain, come back and see me. So, not integrated tests are a scam. How about collaboration and contract tests? Use as needed. Not sure what that means? Ask me and I can help describe it to you. Collaboration and contract tests when you can, integrated tests when you must. Not integrated tests are bad, but just they're not your first choice. Again, sounds pretty reasonable. Prefer composition over inheritance, prefer collaboration and contract tests over integrated tests. We're having pain. How are your integrated tests? That's part of where the pain is. Okay, try collaboration and contract tests. Now, there's still some issues that we need to address here. I'm not going to go into all of them here. I'll just highlight them. There's still lots of antipathy towards test doubles. People don't trust mock objects. And part of that is because they've seen what happens when you have indirection without abstraction. I get it. It's a lot out there. Part of the problem is that I believe that's part of the learning process. I think you have to write those terrible tests in order to understand why they're terrible. And the reason why people get stuck in the pit is that they don't have someone like me that they feel like they can ask for help. I don't know why. I keep yelling at people. You can ask me. It's fine. Programmers don't like to ask for help. They don't feel like they can. They feel like they're supposed to know everything. They have a lack of confidence. Some of them have full-blown, imposter phenomenon. I don't know. But that results in a whole bunch of mock objects are evil things, which we know aren't true. But that's a bunch of noise that we're going to have to keep dealing with, I think, for the rest of our careers. Until everyone switches to functional programming and then thinks they don't need test doubles anymore. They're wrong, but they'll figure it out. It's fine. There's still lots of confusion about the different kinds of test doubles, when to use stubs, fakes, spies, expectations, or actual mocks. And in fact, that's the next point, right? There's also confusion between mocks and mocks. Do we mean mock objects as method expectations, assert was called, or do we mean mock objects, the synonym for test doubles? The best way to find out is to ask. But that's part of the confusion. The terms themselves, Gerard Mazzaro still has that translation table in his book, X-Unit Test Patterns, of this author, when they say stub, means this, and this author, when they say fake, means that. I just, when I saw that table for the first time, first, I was honored to be in it. Second, I thought, that's hilarious. We are so disconnected, fragmented, and disorganized as a community that someone needed to put a translation table in a book. So imagine how hard it is for the poor programmer who's trying to pick these ideas up and thinks that they need to learn it all by themselves. And then you add the whole handcrafted versus factory produced, test doubles. I don't think it makes a difference, but there are people who have stronger opinions. And then, of course, do I use contract tests or integrated tests? So these, I think, are the issues that we need to address over the coming decade. If you are looking for something to write about these things. Flood the market with ideas and let's see which ideas rise to the top. Stop telling people that they're wrong when they say mocks are evil. Instead, listen for how they're right. Good excuse. I wrote an article not that long ago called "You Don't Hate Mocks, You Hate Side Effects." Again, kind of a crappy title, but marketing is hard. Because that's, I believe, what people are pointing to. Again, I think the test doubles and the proliferation of expectations in a test are a symptom, not a cause. And the cause is too many side effects. Either the side effects are tangled or they're too complicated. There's abstraction missing. Too many details are being exposed. And if you are allowing your tests to drive your design, then you'll look at the proliferation of expectations in a test and you'll say, wow, there's too much detail here. I need an abstraction. Now, some people will write articles that are like, see, mock objects are evil. And when you rearrange your design to get rid of the mock objects, then everything gets better. And they conclude from that, therefore, mocks were the problem. That's not how logic works, but look, I'm willing to let people be wrong on the internet if it helps them move in the direction of a design that's ultimately going to be better for them. I'm okay with that. Let them be wrong. It's fine. At some point, some of them will write an article that says, gee, I was wrong. Mock objects were the symptom, not the cause. I've seen the light. There's no rush. I'm not selling mock objects for a living. It's fine. Let people be right for the wrong reason. Now, I don't like to use words like right or wrong here, but in a headline, nuance is not easy to add there. Stamping out test doubles means moving side effects up the call stack. It means moving in the direction of the functional core imperative shell. Great. It means essentially sprinkling some functional programming magic dust on your objects. It means using the dependency inversion principle as if you meant it. Or I like this one. I came up with this one at the end. I was kind of proud about that one. Growing FP-style pure functions guided by tests. Steve and Nat, I hope are you listening? Can you write that book? I think that'd be great. Let people be right for the wrong reason. If they end up joining us in the nice happy valley where the designs are nicer and tests are smaller and feedback is quicker, I don't care which road they use to get there. It's all good with me. And then we can have some discussions over coffee or wine or whatever, talk about our experiences and learn from each other. I think it'll be fine. I would rather reframe the debate that people who are struggling with integrated tests are not doing object-oriented wrong, or functional programming is better than object-oriented. I think it's just, like I said, I'm sprinkling some functional programming on my object-oriented. That's fine. If they want to hate test doubles, let them hate test doubles, just as long as whatever they do guides them to refactor in the direction of a design that is easier to maintain, that is less expensive to maintain, that defers becoming legacy code as long as possible. And as I said, if they want to believe that they got there by ruthlessly eliminating those evil mock objects, I'm okay with that. Again, I'm not selling mock objects for a living, so I can say that. If you're selling mock objects for a living, I understand you might have a different opinion about that. The urgency level matters more for you. But then you can write those articles and keep saying, no, folks, mock objects aren't the problem. They're the symptom. Now, I've seen some stuff about testing without mocks, and I know I mentioned James Shore earlier. I'm going to mention him again. Disclaimer, I have not read his work on nullable infrastructure in detail, but I read some of his early stuff on testing without mocks, and it seemed to have a bunch of mocks in it. Now, not expectations, but stubs, fakes, whatever you want to call them. So which mocks are we talking about when we say mocks? That's part of the confusion I mentioned earlier. Because it would be very easy, and it was easy at the time for me to say, he says testing without mocks, but he's using mocks. Okay, I felt superior for like 30 seconds, but I'm not sure what other value that had. And, there's just a little bit of passive aggressiveness there, I still prefer to detect side effects directly using expectations rather than relying on knowing the details of how the production system happens to react to those side effects at the moment by saving things to the database or by writing a file to a file system or, firing another event. But, you do what makes you happy. There's a fine line. In fact, the only difference between delivering this with passive aggressiveness and delivering this with genuineness is how much they trust you. Because it can sound the same. No matter what tone of voice you use, if they don't trust you, it'll be passive aggressive. And if they do trust you, then it'll be genuine. You do you. I don't love the framing, but I like the results. The bottom line, I don't like the idea of people thinking mocks are evil and that removing mocks is their mission in life. But if they get there, I'm happy. We can use something like clean language to help us avoid the mistake of saying, you're right for the wrong reason. And instead ask a question. One of the magic questions in clean language is, what kind of mocks are your mocks? Oh, so when you say mocks, you mean specifically expectations and not test doubles in general. Okay, cool. Because, for historic reasons, sometimes we use the term for both. Now I understand you better. And so I can now put my giraffe ears on and I can read testing without mocks as testing without method expectations. And I agree with it 127% now. All it took was asking one question. Now, I'm going to ask you, and this is particularly, when I say you, I mean the folks who are selling collaboration and contract test ideas, tools, techniques as a way of earning money. Are you feeling over-responsible for this confusion? Are you feeling over-responsible for people not getting it? Are you trying too hard to convince them what's right? It's pretty common. So there's a wonderful little book called The Responsibility Virus. I highly recommend it. It's where these terms under-responsible and over-responsible come from. And the bottom line is over-responsible means taking more responsibility than you need. Feeling responsible for something over which you have no control over which you have no influence. The confusion about terms is never going to go away. As soon as two people try to use the same words, they're going to mean different things. Now, instead of 2, make it 100,000 and you have a serious problem. The confusion about terms was never avoidable. There was nothing we could do about it. And instead of seeing it as a problem to solve, let's see it as what it is. It's evidence that our ideas are popular. Maybe not as evenly understood as we'd like. Maybe we need to work a little harder or try some different things to communicate them. That's part of what I'm here for. That's part of why I've changed the tone of my presentation. I'm tired of preaching to the converted. That's not my intention anymore. I want to open it up to everybody else. I want to invite everyone into the tent. And so this confusion about mocks and all that stuff, to me, that's not evidence of misunderstanding so much as it is evidence of people paying attention. As Reggie Jackson once said, they don't boo nobodies. So let's go for it. Let's jump in let's go to where the confusion lies and offer to help. And not tell them they're right for the wrong reasons or that they're wrong for the wrong reasons, but to actually listen to them and offer to help. So let's use the old extreme programming joke. It's Chet's fault. Now can we have an adult conversation about how to solve the problem? Who cares? And in fact, it's nobody's fault. It just is. When ideas become popular, they become misconstrued because language is hard. Because understanding is hard, because the way to build shared understanding is to talk to each other, and you can't get that as effectively from a book. That is the law of raspberry jam again. The wider you spread it, the thinner it gets. Not going to worry about this. Now, collaboration tests, I think, are pretty mainstream by now, but programmers are still struggling with losing track of what they're trying to test. They have 12 mock objects. They lose track, and it's difficult for them to understand what's going on. And when they lose track, they get frustrated and they give up. And this is an area where I think we can really help by writing more good examples of how to write good collaboration tests and how to write good contract tests. I think what's missing is the book on how to do collaboration testing well. Growing object-oriented software guided by tests is one, but I think we might need a book with mock objects in the title to get people to really pay attention. I have tried to write this book for 12 years. I'm not going to do it. So one of you needs to do it. Where is the, mock objects for the confused? Someone, please start writing an outline now. I can at least help with ideas, but I can't write this book. It's not coming out. I've been trying for a long time. It's just not happening. I can't explain why. So one of you needs to do it, or somebody needs to do it. Start by just writing better examples. In the meantime, my goal is to present all of these ideas not as a failure of technique, but as a natural part of learning. The falling into the pit with mock objects, the failing to understand abstraction, all that stuff is just, there are things that happen when you try. And the best I can do is to make myself available to answer questions. So now, what are contract tests for, really? Let's furiously get to the conclusion. I think people still have difficulty understanding how contract tests fit into their overall testing strategy. How to write contract tests, there's lots of great tools and documentation about that, but I still think well-meaning people try to write contract tests and then don't understand what they have when they're done. I think this is an area where we need to do better. So I like to say things like, well, start with learning tests and then extract contract tests. Write tests that document your understanding about what that thing does, and then figure out how to extract it to become a test for the abstraction. Or you can think of it as the contract of a thing, an object, a module, whatever, has two parts. There's the syntax, which the type checker will handle, and the semantics. What are the rules? What are the rules of behavior? If you put in this kind of input, you get out an odd number. Those contract semantics, contract tests are a way to document the contract semantics by example. Instead of writing paragraphs that are promises about what you're going to get, preconditions, postconditions, all that stuff. We're not trying to go for formal methods. We're trying to go for documentation by example. And the contract tests are examples of the contract semantics. This is what we mean by that paragraph up there. And this will lead us to clearer published APIs, not just HTTP APIs, all APIs. I don't remember when it was that everybody decided that API only meant HTTP endpoint. Sorry, folks, we've been saying API since, I think, the 70s. Objects are APIs too. So let's try a few pithy ways to describe contract tests and see how they feel. Contract tests are merely examples of using an abstraction, right? We can go back to the abstract test case idea. That was one of the first contributions I ever made to the Ward Cunningham's wiki. Was I fixed a bug. I had to write an adapter to the IBM Enterprise Java Session Bean interface because abstraction because they used an enumeration incorrectly. It was a situation where like there was no element. There was next returned false, but instead of throwing a no such element exception, it returned null. And if you read the documentation for Java's enumeration, I mean, it's been the same since version 1.1. If next returns false, then when you try to get the next object, you're supposed to get a no such element exception instead of null. And was there IBM's access beans. So I found a bug in their contract by using this thing called an abstract test case to show that the problem wasn't merely with one implementation of an access bean, but the abstraction idea, the contract was broken. Their access bean did not behave like an enumeration. That's all it was. A contract test is just an example of how to use an abstraction. And that's it. Do you actually behave the way the abstraction says you should? When you try to hide those details, whatever details are left behind that you expose to the public, do you actually play by those rules or not? Doesn't sound that hard. Don't need a tool for that. Just write a test that focuses on the idea of when I use this abstraction, I expect this to happen. And it doesn't matter which implementation I use. Every implementation should behave the same way. That's a contract test. Contract tests are merely examples of how to use a published API, which is saying the same thing. But instead of abstraction, I said published API. Because published API is more popular, I guess. More people will understand what I mean. And if they think about this long enough, they'll probably end up here. Contract tests are merely documenting the commitments of the supplier. You can depend on these things. These are the behaviors that we commit to keeping stable. This is how this thing works. You can trust us. And if we break our promise, you can yell at us and we will listen. Sounds wonderful. What a wonderful way to earn trust than to say upfront, when I say that I implement that interface, or when I say that this is the abstraction, this represents how I work, you can trust me. No matter what happens, these stuff stay stable. Now, the only difference is that with contract tests, we're testing the abstraction instead of the implementation. Contract tests are merely documenting the assumptions of a client, which is saying the same thing from the client's point of view. When I use you, these are the rules of behavior as far as I understand them. And so this is when you're writing contract tests from the point of view of the supplier. This is when you're writing contract tests from the point of view of the client, but they mean the same thing. When you say it this way, it doesn't sound difficult, I don't think. It doesn't sound unusual. It doesn't sound weird. Where it fits into testing strategy, I think, becomes a lot more obvious. And look, it doesn't matter to me which of these formulations you use. As long as one of them helps you, I'm happy. You can start there and you can learn the rest later. The fact that those four things are equivalent to each other might not be obvious on day one, but it might be obvious on day 1,718. It's fine. We're all waiting in the happy valley for you. You can come when you're ready. And how will we know that our efforts are working? Our efforts to demystify contract tests, our efforts to describe using collaboration and contract tests in a kinder, gentler way. When the memes change. When the memes change, then, as not Gandhi said, blah, 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 then they fight you and then you win. When the meme says this instead of zero integration tests, we'll know we're making progress. And that's all I wanted to say today. Here is where you can find me when I am not chasing my dream as a professional 5-pin bowler. That's where you can find me. You are always welcome to ask me a question. I'll repeat the joke. As long as you're willing to wait indefinitely for the answer, that service is free. And if you need a better service level agreement, we can talk about how much that costs. It's less than you think.
Brilliant.
And that's all I have to say.
Thank you, JB. That was awesome. It was possibly slightly different talk what I was expecting, but I loved the bit about the focus we had on how these things are difficult, and the hardest bit is like communicating the concepts, right? That's that personally resonated with me. I know you've been up really late. And we are slightly running over time. I had a couple of quick questions, but if you want to,
I'm willing to answer as long as you're willing to put up with it. Go ahead.
Okay, cool. Let me just share my screen a second and then take it away from you. So the first one really was, and you did really touch on this. So I'll probably just elaborate a little bit more.
Sure.
And this came up a bit during some of our other talkers during the day. Do you feel like some teams need to fall into the hole before they start solving these problems? As in, they need to feel the pain, and you did kind of allude to this, or do you feel that builds a better learning and understanding for teams generally as it goes on? Basically, I'm trying to say.
The short answer is yes, but so I get a bit nervous with the whole need to feel the pain thing, because that feels a little bit like, well, you need to, because I suffered, you need to suffer, and I definitely don't mean that, but it is true that, one of the things that we know about what motivates people to try new things is when the pain of uncertainty of the new thing becomes less than the pain that they've grown accustomed to. And so I wouldn't say they need to feel the pain before they'll get it, because I didn't feel that much pain, but I was attracted by the ideas and I thought, ooh, this will be better. Some people will come at it that way. But I would say the opposite, that letting them feel the pain longer, I don't think is torture. I think it's patience. That some people, before they really feel like they need to change, need to experience how bad things are. The difficulty is that if you let them feel too much pain, then they learn helplessness and they give up.
Yeah,
that's a very tough balance, and that's why I'm not comfortable saying they need to feel the pain, because if you inflict pain on them, or if you push them in the direction of pain, you risk them learning helplessness and giving up before they get to the good stuff. Yeah, so I'd rather say the pain is part of the natural learning process.
I can understand that as well. Like, yeah, there's a guiding, some guardrails. I think if you're that experienced person with that experience, that knowledge, not to let people get to a certain point, right? But
I worry about guardrails too, because guardrails stop people from gaining experience, right? Experience comes, good judgment comes from experience, and experience comes from bad judgment. So you have to be allowed to make mistakes. You have to be allowed to have the wrong ideas. You have to be allowed to do silly things so that you can understand what's silly about them and then never do them again. I think that's what I mean by the natural learning process. And I worry that a lot of senior programmers try too hard to take away too many learning opportunities from juniors, and they end up being those people who say, well, I know I'm supposed to use these mock objects, but I have no idea what I'm doing. And then we end up with the kinds of tests that we then end up trying to come in and clean up the mess. Yeah. They have to be allowed to do silly thing to learn why they're silly. That doesn't mean that they need to do silly things. They need to be allowed to do silly things.
Yep. Okay. Well put. And also, without any experimentation, we won't get innovation. So
right, exactly. We might find out that there's actually a better idea than all of us in the room know.
Yes.
And usually it's a junior programmer who discovers those anyway.
Exactly. So today we had, and again, you touched on this towards the end. We were talking about the implicit versus explicit nature of schema versus behavior. So we think about like Pact itself, its origins, it might be evolving into something else, but it solves very specific problems about contracts between REST API microservices That's moving on now. And some of the conversations, right? You have explicit sort of network contracts now, like gRPC we were talking about earlier today, and you've got things like OpenAPI. What are your thoughts on schema, sort of the explicit schema kind of behavior versus implicit sort of behavioral problems that something like Pack will solve between testing things like microservices?
Well, so I infer that schema is close to what I mean by contract syntax, the sort of the shape of the thing. What's a valid message to this module? The kinds of things that a type checker would check in a language that has a compile time type checker, for example. And then behavior sounds like it's more of the contract semantics. When you do this, this will happen. These inputs will turn into those outputs. This will cause those kinds of side effects. I think this is an idea that had been missing from what we've been teaching for a long time. That I think that's, again, this has contributed to this idea of people sort of having a vague notion that contract tests, that they should do them, but they're not sure why. And it took me quite a long time to evolve this notion of syntax and semantics by making it alliterative. It's easier to remember, to try to sharply delineate the two kinds of tests that we care about, making sure that the wires will fit together. That's the syntax bit. And then making sure that the components will actually behave sensibly with each other. And that's the semantics bit. And where contract tests really come in is, I think a lot of people had the picture that contract tests were like a substitute for a type checker in languages such as JavaScript, Python, Ruby, where you don't have one. I think that's kind of where you're stuck for a while. And gradually, I think now people are really getting the idea that contract tests really shine by showing examples of what we mean by, when you use my thing, here's how it's going to behave. And I think that's where these tools really have promise, is in focusing on the contract semantic side of things, because that's usually where the problems are. The problems seem much less to be, oh, your message is in the wrong format, or you've called a method with the wrong number of arguments, and really are, you thought we were going to return null, but we threw an exception, or you thought we were going to return, or especially, I don't even know what type of thing you're going to give me. Why don't you show me some examples? And that's where I think really contract testing can continue to become really helpful. I think there's a lot of untapped potential value there. I'd like to see that message be clearer so that people then have a clearer picture of how contract tests are going to help them, rather than just, my buddy, the senior programmer, told me that contract tests were good, so I'm going to shove them in my project somehow.
Yep. I think you sort of alluded to this quite a bit during the talk as well. We were just discussing this offline as well. I think that consumer test first thing as well is often understated in what we push for in the Pack sort of community, and obviously comes from people like yourself. So I have one last question, and this one hopefully is a bit more just personal comment. What would be, if you could give your younger self one piece of advice going through like your sort of journey, and we talked about, I'd love to hear about the origins of the word scam, by the way. What would that be?
Everyone around you really is absolutely doing their best. They are, in fact, not idiots. They are doing their best. They're under stress. They're under more stress than you. And that's why they make decisions you don't understand. So enjoy the fact that you don't even know what stress feels like yet. When you feel stressed like they feel stressed, you'll make the same stupid decisions they do, and they'll make perfect sense. That's the message I would like to deliver to 26-year-old me.
Awesome. No, that's a pretty good message. I think I probably wouldn't be too far off that myself. Okay, JB, I'm going to try and wrap up now. Thank you again for your talk.